Well, we're starting a brand new unit on polynomials, and today we'll be discussing operations with polynomials. So this is our content standard and the math practice that we'll use with our assignment today. You've previously evaluated powers. Now you're going to multiply, divide, and simplify monomials and expressions involving powers, and you're going to add, subtract, and multiply polynomials. New vocabulary for today: simplify and degree of a polynomial. To simplify an expression containing powers means to rewrite the expression without parentheses or negative exponents. Negative exponents are a way of expressing the multiplicative inverse of a number. This table summarizes the properties of exponents. If I was you, I'd pause and put this information into your notes. It'll be handy when you get ready to do the exercises. Recall that a monomial is a number, a variable, or an expression that is the product of one or more variables with non-negative integer exponents. So when simplifying a monomial, check to be sure that it has been simplified fully. And here's how to simplify monomials. It is in simplest form when there are no power of powers. Each base appears exactly once. All fractions are in simplest form, and there are no negative exponents. So let's look at simplifying expressions. We're to simplify the expression a to the negative 3 times a squared b to the 4th times the quantity c to the negative 1. Assume that no variable equals 0. So we're going to rewrite these with negative exponents as a fraction under 1. So we're just simply, if it's negative, we just move it to the other side of the fraction bar. This is the same thing as a 1 over a times a times a. This one has got 2 a's and 4 b's. And this one, 1 over c. We divide out any common factors and simplify. So our answer is b to the 4th over ac. We're to simplify the expression n squared over n to the 10th. Assume that no variable equals 0. So these have the same base, so we're going to move this 10 up, which means we're going to change its sign. Whenever we move it across the fraction bar, it changes the sign. So n to the 2 minus 1, n to the negative 8th, or we rewrite it because it's not in simplest form yet. So we have to write it 1 over n to the 8th because we cannot have negative exponents. Now we have power to a power. So 3a cubed to the second power over b fourth to the second power. That means every term inside this parentheses is to the second, and every term underneath, because see that parentheses encompasses the entire expression. 3 squared is 9. A to the third to the second is a to the 3 times 2, or a to the 6th. And b to the 4th to the second is b to the 4 times 2, which is b to the 8th. Okay, time for you to check your progress. So pause for a moment, come back and check your answer. Did you get y squared, z squared over x to the 5th? If so, very good. Okay, time to check this one. So when you move this one, you have to change its sign. 6 plus 2, so h to the 8th. 6 divided by 3 is 2. 2 squared is 4. R to the second squared. 2 times 2 is 4. 3 times 2 is 6. Very good. Now the degree of a polynomial is the degree of the monomial with the greatest degree. But first of all, we have to determine whether or not this polynomial, whether it is a polynomial. So we have to look at each of the terms. And if we notice, we have 4 to the square root of c. So this expression is not a polynomial because the square root of c is not a monomial. Okay, looking at this one, it is a polynomial, and we add the exponents to all the variables. So 2 plus 7 will be 9. So this polynomial has a degree of 9. This one's 5, this one's 9. Remember, if there is no exponent, it's understood to be a 1. Is this one a polynomial? No, it isn't, because a polynomial cannot have a negative or a monomial cannot have a negative exponent. So 3x to the negative 1 is not a monomial because x is in the denominator. You cannot have any variables in the denominator. Okay, time to check your progress. So pause for a moment, come back and check your answer. Yes, it is a polynomial. Each one of these are a monomial each term, and 2 plus 3 is 5. Very good. How about this one? Did you remember earlier the square root of c is not a monomial? Very good. This one is not a polynomial. Try again. You probably figured this was a polynomial, but did you forget to add that 1? 6 plus 1 is 7. Okay, good practice. You can simplify a polynomial just like you can simplify a monomial. You're going to perform the operations indicated and combine the like terms. So this one we're going to distribute this negative 1 across the parentheses. So it's just in essence going to change the sign of every term inside the parentheses. We're going to group our like terms, so a to the third together, and our constants. And then we're going to combine our like terms. So the answer here is a to the third plus 8a minus 9. Okay, let's try another one. Now this time we've got a plus sign. They're going to align the terms vertically and add. So they're showing you two different ways that you can go about solving this and see which one fits you better. So 4x minus 2x squared is 2x squared. Both of these are negative, so you add. And the difference of a negative 6 and 3 is negative 3. So whichever way is easier. This one was very simple because of the plus sign and you didn't have to distribute the negative 1 first. So you can work with which one feels most comfortable to you. Time for you to check your progress. So pause, come back and check your answer. Negative x squared plus x plus 2. Did you get that one? Don't forget you have to change every sign inside the parentheses. So if you got it off, maybe that's where you missed. And a negative times a negative makes that 5 positive. Let's try another one. So pause and come back and check your answer. Did you get negative 7x squared minus 5x plus 6? Excellent. You remember to multiply, distribute this negative 1 across this set of parentheses. Now, adding or subtracting integers results in an integer. So the set of integers is closed under addition and subtraction. Similarly, because adding or subtracting polynomials results in a polynomial, the set of polynomials is closed under addition and subtraction. So now you can use the distributive property to multiply polynomials. So we're going to multiply this negative y times each term inside the parentheses. And when we multiply, our answer is negative 4y to the third minus 2y squared plus 3y. Okay, time for you to check your progress. So pause and come back and check your answer. Very good. Negative 3x to the fourth plus 2x squared minus 5x. Awesome job. Here's a real-world example. I'm going to pause for a moment and let you read the problem. In words, we have revenue minus cost. So our variable we're going to use is x. That's going to be the number of units So the equation, we're given 10x minus 1,000th x squared plus 5x plus 500. So they give us the expression of a particular product. So now we're going to use the distributive property, distribute that negative across the parentheses. We're going to combine our like terms. So the polynomial expression will be negative 1,000th x squared plus 5x minus 500. So, time for you to work your magic. Pause and then come back and check your answer. Okay, did you notice that the difference between 2.2% and 1.9%, that's what we need to multiply. That's how we get this number, and using x for our variable. And 24.7 is the 1.9% times the 1,300. All right, moving on. Like addition and subtraction, polynomials are also closed under multiplication. So we're going to use the distributive property. We're going to multiply the a times every term in this set of parentheses and 2 times every term. Or how they've shown it, they've multiplied a squared by both of these terms, 3a and negative 4. So we've multiplied the monomials. Now we're going to combine our like terms. So our answer is a cubed plus 5a squared plus 2a minus 8. Time to check your progress. So pause and come back and check your answer. Did you get x cubed plus 7x squared plus 10x minus 8? Very good. That means you are ready to begin the assignment.